Question says an air-filled parallel plate capacitor has plates of area 2.7 centimeters squared separated by a 2.5 millimeter distance. The capacitor is connected to a 24-volt battery. Find the value of its capacitance, the charge on the capacitor, and the magnitude of the uniform electric field between the plates. So I'm just going to go ahead and write down my known variables in standard units. So I have an area, so it tells me that I have an area that's equal to 2.7 centimeters squared, which is going to be 0.00, and one more 0.27 meters squared. Now, typically when you go from centimeters to meters, you times it by 10 to the negative 2. But whenever you're going from centimeters squared to meters squared, you have to go 10 to the negative 2 and multiply that negative 2 by whatever dimension you're raising it to. So in this case, you're raising it to the second dimension, so you got to multiply by 10 to the negative 4th. I could show you why that is, but it would take too long, so just remember this rule here. Whenever you're raising to a specific dimension other than 1, you have to multiply your conversion factor by the dimension you're raising it to. And not the conversion factor per se, but the exponent on the conversion factor. So that was my area. And it says I have a distance of 2.5 millimeters. So I'm going to take that times 10 to the negative 3, 0.0025 meters. And I have a potential of 24 volts. So a potential difference of 24. And the other key thing that it tells me is it says that my plates are air-filled. Now, if you look at a dielectric table, so the dielectric constant of air is 1.00059. So it's basically equal to 1. Which means we can actually ignore the dielectric constant in this problem if we want to. So our formula for capacitance is equal to the dielectric constant times E times A over D. Now E, you remember E is equal to 1 over 4 pi times K, where K is Coulomb's constant, 8.987 times 10 to the 9th. So E is approximately equal to 8.85 times 10 to the negative 12th. So if you just simply multiply the 8.85 times, and see 1.00059 is so close to 1 it's ignorable, so we're going to ignore this K, and that's what K is in this particular equation. It's the dielectric constant. In this one it's Coulomb's constant, so to confuse you. And then you're just going to multiply by the area, 0.00027, divide it by the distance, which is 0.0025. Now the answer is supposed to be in picofarads, so feel free to multiply your answer times 10 to the positive 12th, and so you should get an answer of 0.9. If you didn't use the dielectric constant of air, then you should get 0.95631. If you did use the dielectric constant of air, you should get 0.95687. So there is no difference for the first 3 decimal places. Not until the 4th decimal place is there a difference. Now the next part of the question is asking us what is the charge on the capacitor. So remember the definition of capacitance. One of our earlier definitions was the ratio of the magnitude of the charge over the magnitude of the potential difference. So we can actually solve for our charge, and so Q would equal the capacitance times the potential. So since we're staying in picos, we actually can just go ahead and throw in one of these two numbers. So we would put 0.95 times, and then our voltage was 24, so 0.9568 8 times 24. And it should be, the charge should be roughly 22.965 picocoulombs. And so for the last part, we can go back to a much earlier equation where we said that voltage was equal to E times delta X, or E D. And then we can solve for E, so E is equal to voltage divided by the distance, or voltage divided by the radius, however you want to say it. And so the distance, remember, was 0.0025 meters, or 25 millimeters. And so in the voltage, again, 24, so 24 over 0.0025, and you should get 9,600 newtons per coulomb. I do appreciate you watching. If you have friends that are taking physics, need help, you think they could use the video, make sure you email it, share it on Facebook, tag your friends that are in your physics class, and spread the word. And last but not least, make sure you click like and subscribe. The like button, you can see this picture I drew of me. He's looking down in that general direction, down at the bottom of the screen. And very, very last thing, if you have any questions, if you're on my blog, leave a message down in the comments, and I'll get to you as soon as I can.